Hi, welcome back everybody. I got a pretty interesting item to tear down today. It's a nuclear spectroscopy unit. It's like half of the unit, the other half was up above it, which was like the which would display the actual spectrum graph and the relative energies, I guess. I don't know much about this nuclear stuff, but I think electronics would be in here would be pretty cool to look at. Might be some pretty interesting things in there. What I've seen from the date codes is that this unit's about from the 1970s, late 1970s. So you'll see some pretty extensive use of through-hole components and dip packages. It's made by a company called Canberra. They're still operational. They almost sell the same unit even today. It's pretty amazing that they would still sell the same model numbers. So this bottom unit didn't have any connections on the front. Everything was made on the back. All the connections to each module was linked together, and also linked to the top unit, which was like the main controller for the whole thing. And it used all these little different pieces to measure the energy of the nuclear particles or something. So what we got here is a high voltage power supply. It looks like it can go up to 2 kilovolts, 0 to 2 kilovolts, positive or negative apparently. And it's got a 10-turn potentiometer on there with a nice little radical display that counts up, so you can get a pretty accurate count on there. On-off switch. And the next unit is a amp/TCSA. I don't know what that means, but some sort of amplifier thing. It's model number 2015A, and the high voltage power supply model number is 3102. I guess what's also new is that I've got a website now where I'm posting more blog type things. It's double and then electronics.net. I'll put the link somewhere right there maybe. What we got next is a nuclear counter, model number 1775. It's got a little LED display, it says, and little push buttons on top. Start, stop, reset. Looks like it can count the frequency, like square wave pulses. It apparently goes up to 25 megahertz. I'm right, if I'm correct on that. Time counts, I'm not sure. Those do positive threshold. Must be the threshold where it actually triggers and that says the count. Some sort of preset. Not sure exactly what this thing does, but you can toggle each of these switches up and down, and also a positive negative switch. And in the bottom it says signal and it says gate. So that's pretty cool. And each of these units you can loosen up these 2 screws and just pull it right out. So that's what we're going to do soon. The next one is a Linlog rate meter, model number 1481LS. So it looks like they've stuck some things on there, some stickers on, and also wrote with just a regular pen to adjust. I don't know why, but they must have modified it somehow, or that's I don't know. I mean, looks like it's done pretty professionally. Might have been done in the factory, for all I know. It's like they're using the same kind. They're using like silverback plastic, which matches the actual aluminum in the back. So it could be done at the factory, I'm thinking. So one is linear, one of these scales is linear, and then one of them is log scale. So you can adjust. It's like two different things in one unit. It's kind of cool. Positive negative switch, and you can either select log or linear scale. What we got next is a spectrum stabilizer, model number 2050, which I'm totally not sure what it does, but it's got a switch to change the window width from 0.1 to 2, some sort of a spacing control, which I have no idea what it does, peak position, another 10-turn potentiometer, low drift and high drift, whatever that means, calibrate and operate switch, and it's got this handwritten, just markered in 6 and 7 on there. I'm not sure what that does. The next unit we've got is a spectroscopy amplifier, model number 2010, and the coarse gain, this coarse gain control from 10 to 3000 gain, which I don't know what that does. Apparently it's an amplifier, which is specially made for spectroscopy units. Fine gain, another nice 10-turn potentiometer. Pole 0. It looks like another one of those 3.5 millimeter connectors. Shaping. That's no idea. A 3-position switch that's under the restorer name. I'm not sure. And the way there's like this black dust covering the whole unit. I'm not sure what that is. It's like it's just coded and everything on this unit. Not sure how it was like where it was stored at, but it's just everywhere. Threshold switch, polarity input, positive negative, unipolar output. No idea. Input, output. Output, and one's a unipolar output, and one's a bipolar output. Which it's no idea what that does. But the last unit is a high voltage power supply, model number 3002, and it looks like this goes up to 3 kilovolts. And it's got a little volt selector range. It's from 0, 500, 1000, 1.5K, and then 2K range. I'm not sure why there's a 3 on the scale, though. It might go up to 3 when you crank it all the way up. And it's also got this really nice dial gauge, which will tell you the voltage on this thing right here. Here's this dial switch I was talking about. You can select the voltage very, very nice with this. It has radicals down to this 5, so 0.2 volts in between, or 0.2. Resolution of 0.2 on there. That's really nice. What if we go all the way up to the top? Oh, okay, it just resets back to down. Goes to 999, and it goes right back to 0 again. And it's also got a little, that's like a selector for how much resistance it has. So we can really fine tune it. If you crank this all the way that way, it's really tough to move. But if you crank it all the way this way, then it's really easy to move, and it's got like a range in between that. So that's a pretty nice feature. You can really dial the voltage in really good. That's pretty nice. And just a regular on-off switch. And this last unit is a very, 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 very skinny. It's like a permanent mount and enclosure. the little, it's got a little tiny little voltage outputs right here and a ground. So it's got plus 24, minus 24, plus 12 and minus 12 volts and a ground. It's also got a temp indicator and a power switch. So that's everything for the front. We'll move on to the back. So here's the back of the unit. Looks like this is like just a power supply that was strapped on the back that supplied voltage for all these other modules except for the high voltage module right there. So looks like it outputs negative 24 volts, negative 12 volts, plus 12 volts, and plus 24 volts. With them, it's a model number 2000P. Looks like it's a linear supply, which is very typical of the day. It's uses 4 very large TO2 packaged bypass transistors right there, and a nice chunky heatsink, black anodized heatsink, which is pretty nice. Everything on this unit is just very nicely machined. There's no burrs anywhere on this. Even when they cut the holes for these screws right there, there's no burrs at all on this thing. It's very nicely made. So on the back of the high voltage supply, there's 2 transistors in the back with a nice little chunky heatsink again. Two high voltage outputs, and this is a special output because it's got a inner jacket which protects you from, in case the supply is on, it protects you from actually reaching in there and getting yourself electrocuted if it's on without the cord. And then there's also versus a regular BNC, which you can ooh, this one's kind of loose, where you can almost touch the inner core, which would be bad at a very high voltage output, because that'd be very bad. And then there's also another fuse, dedicated fuse, which is pretty nice. And on the back of this, a spectroscopy amplifier. It's loose cord right there. 93 ohm output. That's pretty not typical. 93 ohms. I wonder where they got that from. Usually it's 75 ohms or 50 ohms. But this is a 93 ohm output. Not sure what the standard is that they're using there, but this is a pretty interesting switch, I gotta say. So you have to pull the switch out before you can switch it up. If you pull it out again, if you just try to toggle it without pulling it, then it doesn't work. So that's pretty nice. Would prevent the cables from accidentally, just in case the cable were to go down, it wouldn't trigger the switch to a different range. Hey, that's pretty nice. And then finally, we've got the last high voltage output stage, which has a high voltage connector on there. Looks like a little nice BNC. I think the first thing I'm going to take apart is this back power supply right here. Looks like it's got a whole bunch of Phillips screws around there, so I could just take a peek inside there and maybe do some cleaning in there and look for bad capacitors. Because the top unit that I took apart, the whole linear regulator stage was the capacitors were blown out of it. Okay, let's put the lid on this. And there we go. Looks like we've got a linear, like a really big giant transformer, which is just covered in this black dust. And it looks like we've got two circuit boards right here. on some really ancient capacitors. Take a closer look at. Just peek in there quick. I wonder if these boards just pop out. That'd be pretty nice. Oh yeah, there we go. Yeah, wow, that's really nice modular construction on that. So it looks like you've got a few of these little tubular, they're like paper capacitors, and then 2 electrolytics. Some random bits and bobs of passive and active components, and diodes. The classic 741 op amps. I always need a 741 in your design. Yeah, these, you can see that it's so sounds actually not so bad though. It's not too bad, but some of the other ones are just absolutely just gross. What's this? 2N4036. It looks like it's a transistor, and there's another one right there. You've got 2 of those capacitors that have been bulged out again. Right there. Looks like they're 2100 microfarads, made in the USA. Very nice. And even got it labeled too. Model number 2000P, Canberra NIM BIN power supply, negative voltage board. So this, yeah, negative voltage board. Pretty nice. And the connector that it came in is just looks like a very nice backplane connector. It's very nice thick traces on there. Very nice. Wow. Just massive thick traces. And let's plug that one back in. I'm going to do a thorough cleaning on this, I think. A little crunchy. Let's take out this one right here. Yeah. Ooh, wow, look at the back of this board. Very nice hand tape traces. So looks like the still Canberra 2000P power supply. Is that it? Nimbin power supply. Side A. These very nice thick traces on there. Looks like it's been hand taped out. Classic design. So capacitor's been pushed over so easily. Some more electrolytic capacitors has seen better days. Look, oh man, those are pretty crusty right there. Pretty crusty capacitors. And it looks like they've keyed these things, so you can't put the positive board in the negative side. That's pretty nice. There's a little slot cut out in there, and on this connector there's like this little piece of plastic right there which prevents you from inserting it in the wrong place. Pretty nice wiring in there though. They get zip tied. The little cable loom that is hand zip tied. Very nice. Very nice indeed. I don't know if I like these boards just sitting in here, because there's really nothing holding them from just going back and forth like this, just vibrating back and forth. There's no like container clip or anything. They just rock back and forth. And it looks like my hands are all I don't know what this is, but It's just, everything's just coated in this black stuff. Okay, well here's the inside of the power supply. You've got a power switch right there, on-off switch, 10-turn potentiometer, the voltage selection switches, LED, and a clear voltage range dial right there, and you can see the coil right there. Then there's just another LED right there. But this section, this is like the high voltage section right here. Looks like, because it's entirely potted in a silicone type compound. This BNC connector goes directly into this block. This is a high voltage BNC, by the way. But yeah, this board also connects to this like backplane type connector with this amp connector right here. This connector extends all the way over to the potted region of this supply. So what's in this little section right here is, it actually is pretty clean compared to the rest of the what we've seen in the low voltage power supply. Actually looks pretty clean. Let's take a look at a few of the chips. Got a nice little ribbon cable right here, rainbow ribbon cable. That was nice to see. And some chips, CA324DE, to look that one up. Looks like another identical chip right there, CA3140E. Texas Instrument chips. Looks like some sort of op amp kind of configuration. TL. It's upside down. TL082CP. Looks like almost like another op amp. Oh. They've got two big, I assume, transistors right there, made by Texas Instruments. Looks like just a bunch of op amps and two big switching transistors right there, and maybe some regular capacitors, resistors, diodes. Kind of very simple topology. It's kind of interesting that they're using this board edge connector to connect all these wires, and this might make easy repair if you can just swap out this whole board if it needs to be repaired, instead of trying to desolder stuff or unplug connectors. Everything's pretty modular in this type of setup, so I really like that. It's just a regular connector back here, some sort of passive component in there. I think those could actually be fuses too. They kind of nice, put a little zip tie on those, and they're nice and secure. That's pretty nice. All right. Well, I think that's all for this high voltage power supply. be posting pictures of this after I get it cleaned up, and I'll be posting it on the website, so stay tuned for that. It's like mirror finish on there. That's pretty nice. Still a little bit of rust around the edges, but very nice mirror finish. That looks like it's not reflective. Okay, here we go. Looks like an entirely through-hole components. A lot of little dip tantalum capacitors on here. These are selector switch, 3 potentiometers, and then 2 BNCs. And then there's also some BNCs in the back. Some miscellaneous switches. Look also very nice. So closer up. Whoa. What is this thing? Looks like a seriously multi-gang switch. Wow. Even. What are they doing that for? It doesn't even. What is that? I have no idea what they're using this for, but there's this internal switch you can push. It's not. There's no like click action or anything. It's just like a very tough to press. I have no idea what that is. The function of that in the circuit is. Looks like there's about 3 sections to this board. There's this section over here, which looks like this main chip right there, and then there's this section right here. This could be like some sort of analog board. There's lots of transistors right there. And there's this section up here, which looks like there's like a few op amps, and then some sort of logic circuitry. There's a pretty big transistor right there. Taking a look at the first section. Looks like you've got an op amp right here, some sort of op amp, depending, just judging on the pin package, how much pins there are. That is the 2515-5. I'm not sure, doesn't sound familiar, but I'm judging that's an op amp kind of deal. Oh wow, look at this TO92 package. It's got a pretty nice heatsink on there. Nice little clip-on heat sinks on those TO92 packages. Haven't seen those before. Oh, interesting. And it looks like there's some sort of op amp package right there. Just look how much leads are coming out of it. Some more TO92s. And then this chip right here is the CA30968E, made by RCA. I don't know what that's for. And then this is the UA711CN. That almost looks like a quad op amp or something. Just, yeah. And there's so much analog stuff right here, apparently. Just a lot of discrete components, capacitors, resistors, these high precision resistors right there. Yeah, pretty nice. And looking up on the top, we have 741 op amps, 741, 741, and looks like a ceramic type package. They're not plastic packaged, they're ceramic. This is the TL510JG. Those must also be op amps too. Just looking at the pin, can fit like just the package type and just the location of the op amps. Those are probably the op amps too. I could be mistaken. And this looks like some sort of transistor. Yeah, 2N219A. Yeah, that sounds like a transistor. And then right here we've just got 7/4 series logic. We've got throw this back in the unit. This is a double length module now. Sandwich of 2 circuit boards in there. This is the nuclear counter. It's nice how it just slides right out. Hey, oh, I got the back of it. But you can check out the big huge transistor. In the back, the 2N3055 transistor, maybe RCA. And 2 giant electrolytic capacitors, which they don't look too bad, but I wouldn't trust them too much. They're made by CALL Callan's capacitor. I've never heard of that company before, but it's a 19,000 microfarad 20 volt capacitor. Very nice. And up the top right here, it's just got a linear transformer right there. Very small bridge rectifier right there. Just judging on the 4 pins and the mounting on the chassis. So this must actually have AC coming into this board. And it looks like just some BNC connectors and just a regular switch. Looks like I got some sort of type of board sandwich going on. This is the other side of the unit now, and the board's still facing us the wrong way. How they dig the whole thing apart like in half right here, or I don't know. HP LEDs. The HP model number is 5082-7730. I like that HP logo though. It's very old school. Must have been one of their first logos that they made for the company. Oh, there we go. There's a screw down here that I missed. See if we can take that one out. Oh, there we go. Oh, wow. Wow. That's, wow. That's really nice. See these? There's these things that pivot right there. So you can just open this thing up. Looks like when you disconnect this connector right here, so don't break it, to get it all the way open. It might be easier to disconnect this bottom one. There we go. Got this stripper board sandwich propped open. Looks like we've got a top board right here, and then the bottom board right there. There's that transistor right there, and then the capacitors right on the other side right there. So let's take a closer look at the top board. Looks like we've got some just a lot of 7/4 series logic chips, whole stacks of them right here. Lots of 7/4 series. Looks like you got some pretty special packages right there. Maybe Texas Instruments. Just absolutely massive tantalum capacitors right there. Another 741 op amp. Just massive tantalum, dipped tantalum capacitors. Just massive, wow. Like some sort of crystal. Very big. CL19 Clark. Some sort of very big crystal. It's got some sort of, looks almost like PTFE mounts right there, and then the gold things going into the circuit boards. So those would be pretty fancy little crystal right there. Looks like just 7.4 series logic right there. Looks like one of those fancy op amp packages, and then just wow, look at this row of just passives, some diodes, some resistors, just another row, just a giant row of ceramic capacitors. Nice little ribbon cable. Very fancy. Now let's just take a quick look at the bottom board. Looks like we got just some more rows of 7.4 series logic chips. They're standard chips. And look at these bars that go across. You can get a close up of those. Looks like you can see the bars right there. Those are either power or ground on the chips, so just to provide a lower impedance path for all the chips, and also just to provide a lot easier routing too, because these are actually suspended above the board, which you can then you can fit trace underneath it without having to get a higher layer board. I think you're just using the double layer board right now to do this routing, but that saves them from doing a higher layer board, so having it up above. These are kind of nice little dip connectors. You just plug them right in. Right now the cable's a little too short. I had to unplug it to be able to open it up. So now we just got to plug in the cables again, I guess. Ah, nice. Yeah, just plug it right in. Yeah, that's rather nice. Oh, look at that little note on this one. Oh, that's pretty nice. Looks like a Dear Sir. Something on a warranty. Oh, that's kind of nice. But anyways, looks like there's this main rail right here, and there's this rail right on the side, so that must be where this edge part around here lines up with. But since I put it on the wrong side, it doesn't fit in there anymore. It goes all the way back. Let's just take a look at the back section of that. Looks like there's some nice gold contacts back there. Yeah, looks like pretty nice gold. Almost looks like a standardized pin, like a pin location thing. Each one's certain voltage and ground, and then maybe 120 volts coming in, or the line voltage. There we go. So this video has probably went on long enough, so I'm gonna post up this part as like the first part of this video, and then the rest of these are gonna be for the second part of the video, which sure it's going to be like almost like an hour video, so it's going to break it up in 2 parts just to make it easier to watch and to keep record of. And by the time this first video is posted, I'll have pictures of all these modules, high detailed pictures of the insides, and also try to track down the service manuals for each one